Good afternoon and welcome again. Today our esteemed guest is Dr. Ish. So we welcome you on behalf of NADCL and on behalf of participants and on behalf of dignitaries. So is Professor and Head Department of Remote Sensing and GS Canada University. So please continue.
Okay, madam. So my topic is basically geospatial technology. I will cover three parts. What it will start with an introduction to geospatial technology, then how to go for a mapping. In mapping technique, I will cover about wetlands, coastal area, then fishery sector, if and veterinary sector. Then finally, where you can collect the data, because there is a lot of data is available in different platform, maybe in different Google or different sites. If time available, I will show you from where you can download data free of cost. And nowadays we are working on open source data as well as the open software also. So nowadays the software is very costly. So there is a lot of OGC data are available, as well as the software is also available. So I will start with maybe this terminology may be new for you. You heard about bioinformatics, hydroinformatics, geoinformatics, lot of terminology. Here, geospatial technology is nothing but it refers to all technology. It includes remote sensing, GIS, GPS, all the things. So you are familiar with geotagging. Nowadays, you are taking a photograph from your mobile. When you switch on your location, you are getting a geotagged photo. Suppose you are going to the field for collection of flora or fauna. You want to take a location, you just switch on your mobile, this one, location status. Then you go for a photographs. It is a geotag photos. These photographs you can directly input in a Google platform also. It is having a latitude and longitude. Nowadays you are familiar with the DigiPin of postal service. The same thing, everything is a location based nowadays. Suppose you are going to the field for a different seasons, you are collecting first season for a more than 100 samples. The same next season also you have to get a sample from the same location, maybe in based on your purpose of your project. Then there's a word called geofencing. Nowadays you are using a social platform like a Facebook or Insta. You can do a geofencing. Even in the COVID time also, you are putting a virtual fence. Suppose you are standing somewhere in the mid of India, you can do some geofence, some 30 kilometers. Nobody can, it's a virtual fence. So there's a lot of advancement in technology in the geospatial part. So this is a overall look on geospatial technology. Nowadays, there is a lot of scanning mechanism is there. One of the technique is called LiDAR. So if you want a high resolution map for a centimeter map, we are going a LiDAR. That's a light detection and ranging. I will explain later slides. Then radar is there. Usually when you go for a mapping, you usually in monsoon season, there is a lot of clouds in the atmosphere. You will not get any photographs. Once you are taking a photographs from the aeroplane or from satellite, it will be masked with these clouds. So the radar can give you the correct picture. Even there is a rainfall, smoke, or a haze, all the things the radar can penetrate. That's the advantage of radar remote sensing. The LiDAR is an active optical remote sensing. So the importance of Earth observation is there. So there is a lot of satellites are orbiting. There is a constellation of satellites, both belongs to India and Asia or Europe or US. There is a more than 1,044 satellites, working satellites, out of 36 belongs to India with a different name, like an OceanSat, ResourceSat, Cartosat, or RISAT. Because once you are interested in ocean, you can go for an OceanSat satellite. There is a sensor called OCM, Ocean Color Monitor. It will give you the percentage of phytoplankton in ocean, all the things. Suppose you are interested in resource, there is a resource sat is there. Suppose you want to go for a high resolution mapping, there is a Cartostat data is there. Then there is a satellite called RISAT. That's a radar imaging satellites. Then nowadays we are also familiar with the aerial mapping. Sometimes your satellite is in the orbit. Suppose some event happened, shipwreck or marine, anything for a flooding. That time your satellite is not in the orbit. Your aircraft will help you to get a data. So nowadays, UAVs and drones play an important role for both for our natural resource mapping, whether it is in the water or it is in the whether it is in the terrain also. So these satellite aerial photos and drones will serve you a lot of application, especially for a terrain as well as a ocean. So then we are going for a GNSS. GNSS means Global Navigation Satellite System. It is a positioning system. Each country having its own system. If you see the Europe having Galileo, the Russia having a GLONASS, US having a GPS, then Beidou, Compass. So India will achieve NAVIC. NAVIC is our GPS constellation of satellite, but NAVIC is not operational. Maybe it is operational in 2025. Then you will get a better resolution for your data. So why we are very important in GNSS? Because nowadays you are familiar with the Swiggy, Uber Eats, all the things. Suppose you order the first time, sometimes it will show you a different location. So to increase the positional accuracy, so India developed our own system is called NAVIC. So it will be operational in 2025. So whatever the data you are getting from a satellite or a GNSS or a scanning, everything you are putting in a common platform, you are calling as a GIS. GIS is called a Geographical Information System. So you are getting a data from a different platform, maybe from your mobile camera or from a satellites or from an aircraft or a drone. All the information you are putting in a common platform, you are calling as a geographic information system. But there's a lot of development of GIS also. When we start GIS in 90s, it is a desktop GIS, then it is a called mobile, then internet, web, cloud GIS, like that. There's a lot of development in part of GIS also. There's a new GIS is called a GeoA that we are calling as a GIS plus artificial intelligence. So nowadays we are talking about machine learning and AI. There is a lot of application in the fishery sector, in the veterinary, as well as in the terrestrial pattern also. So why AI is important? Suppose you will go for a precision farming. Suppose the AI will help you for a precision farming. Then there's a new branch of GIS is called a health GIS. So there's a lot of application for health GIS to monitor, to surveillance, and also to study the hotspot areas for a different disease, whether not only for the human beings, for the cattle also, we are using a GeoA for to monitoring the movement of lives, all the things you can do with that GeoA. The thing is that the data set is very important. Based on your data sets, how your output will be look like that. That is why AI and machine learning will play an important role in any sector of our life. So these are the some of the satellite. Before starting this class, I will say two terminology. One is a remote sensing and GIS. Remote sensing is nothing but you are getting an information without having a physical contact. That you are calling as, that's a simple definition of remote sensing. So you are taking a photograph with your mobile, it's a remote sensing, right? So what we are talking about from satellites, there's a lot of satellites in orbit. So this satellite will help you to monitor your Earth as well as the ocean, atmosphere, all the things with a 24/7. So you are getting a data from a different platform with a different altitude, with a different resolution and different application, right? Based on the structure of your project, your type of satellite will be different. Your type of sensor will be different. The type of resolution is very different. Suppose you are working on ocean, you need a coarse resolution. But you are working on land, you need a high resolution data. So Based on the type of your project, the data set should be different. So what GIS will do, GIS is finally for mapping. Suppose you are getting a data, you want to go for any type of geostatical analysis or any type of spatial planning, how spatially it is changing, whether it is a seasonally or monthly or yearly, there is a variation of chlorophyll. All the things you can study from satellite data and also from a GIS platform. So these are the different satellites operating in different application. The some of the satellite you are calling as a weather satellite, usually NOAA, AVHR, then the advanced very high resolution radiometer, then the DMSP, Defense Meteorological Satellite Program, and INSAT is belongs to India. So Indian National Satellite, it will give information about the movement of clouds, the movement of cyclones, everything you will get a daily from INSAT. Then we are interested in land observation and marine observation satellites. The land observation, there's a lot of satellites like a Landsat belongs to US, the Spot is belongs to France, then IRS belongs to India, Indian remote sensing satellites. So then there is a lot of marine observation satellite to study the ocean. It include OceanSat, then Nimbus series of satellite. It includes CZCS, that's a coastal sort color scanner. The OceanSat having one sensor called the OCM, Ocean Color Monitor. So these are the data you can download free of cost, right? There is no need of paying any money. You can download all Landsat data from to 1 to 9 series of satellite. The ninth is a new version with the sensor name is called OLA, Operational Land Imager, with a resolution of 30 meters. So this data, there's a lot of application for sea surface temperature mapping that you are calling as an SST. And also you can go for an LSD also, that's a land surface temperature. Suppose when you are talking about thermal bands, if anything related to temperature, we are using a thermal bands. So there is a lot of application for Landsat to study the SST, that's a sea surface temperature. Then the Spot is a French satellite with a 10-meter resolution that also you can download from internet. Then IRS series of satellite, it includes already explained OceanSat, Cartosat, ResourceSat, all the things. Then NOAA, Equinox, Radar, but you have to pay money. It's from Canada. Then there's ALOS is a Japanese satellite. The final one is a Sentinel. Sentinel also very beautiful data. It is also free of cost. You can download from internet. That's Sentinel data. So this is only the small example of ResourceSat. It's a lot of application. I have not included this OceanSat. So here you have to see there's a 3 satellite image on the right side with a different resolution. One is a 188 meter, the second is a 23.5, and the third one is a 5.4 meter resolution. Here you have to see all satellite data we are representing in a false color composite. But you know, when you go for a Wikipedia, Bing Maps or Google Maps, you are getting a weightation as a green color. You know why it is a green color? Because of when you say biologically, there is a presence of chlorophyll. If physically, there is a green light is reflected more compared to another part of electromagnetic spectrum. So here we are putting weightation as a red color that we are calling as a false color composite. If time is there, I will explain you later why we are using a red color for vegetation. So this is one of the images from OCM, that's the Ocean Color Monitor to study the ocean properties. When this is the first image of Earth observation satellite, the sensor name is OCM. Date of acquisition you can see is 2022. When you can see the part of Gujarat, you can see there is a spectral variation of color of water when you near to the bay or this one Gujarat. You can see because of high turbidity, the color is different. Once you are seen in the Arabian Sea, you are getting a dark blue color, but inside you are getting some bluish tint like that. So the turbidity is very high. near to the coast. When you go away from coast, the turbidity is less. That is why you are getting this color. From this data also, you can derive phytoplankton. That's a chlorophyll A from an OCM data. So the phytoplankton is again related to any type of your primary productivity. So this is another data for Photostat 2A. It is launched in 2008. From OCM and Landsat data, you will get an only X and Y. But the Photostat 2A, you will get an Z information. You will get an height information from Photostat 2A. So this is a microwave remote sensing. So it can operate both day and night, irrespective of sunlight, and also then you can use this microwave remote sensing irrespective of time, rainfall, or fog, or any type of atmospheric condition. So this is a advanced. It is not advanced. It is already emerged. You are calling as an hyperspectral remote sensing. These are basically what we are using for a one of the satellite called HISAIS is a hyperspectral imaging satellite. So it is basically to study the agriculture pattern, the glacier, forestry, all the things, the coastal landforms, inland waters from a different angle than that of that of microwave and this one. So when you sum up all these slides of remote sensing, it included black and white image that you are calling as a panchromatic. You are getting a multispectral. You are getting a more than 2 bands. You are calling as a multispectral. Then there is a microwave remote sensing. You can operate irrespective of time. Then there is a thermal remote sensing. It is basically related to anything related to temperature. Then there is a hyperspectral remote sensing. So these are the different type of remote sensing. And also you have to keep it in mind, the remote sensing, how you are using, that is a based on your project. So what is your objective of your project? Based on that, you have to select what type of remote sensing. Suppose you are using for a forest fire mapping, then you have to use a thermal remote sensing, right? Suppose you are mapping for a flood, you are using a microwave. Suppose you are using for a phytoplankton studies, you are using a multispectral. Suppose you are going for a precision agriculture mapping, you will go for a hyperspectral remote sensing. So based on your project, things will be different. So the LiDAR is one of the advanced technique nowadays we are using. This is one of the instrument we are using called Luminous. It is from Australia. This is our part of the project. The CUFOS is a part of NISR. I think you are aware about NISR project, NASA ISRO, synthetic aperture radar. To find out the biomass, this is a biomass of Shimoga using a LiDAR technique to what is the tons per hectares like this. So these are the nowadays drones will play an important role. And this is one of the drone image. On the back side, you can see Indian Institute of Management, IIM Calicut. In front side, it's one of the R&D institute under Science and Technology called CWRDM, Center for Water Resource and Development. This image, it's a high resolution data. So you will get an X, Y, and Z. So X and Y is basically, we are calling as a latitude and longitude. Z, what you are saying, height of the building or height of the terrain. So this is a part of the project. We are currently the second phase is also going for a NISR program. So nowadays we are getting a high resolution satellites, but you cannot purchase any satellite data below 50 centimeter resolution. That means, so resolution means a size of a pixel, right? I will show you what is a pixel. So these are the satellites with a high resolution like QuickBed, WellView 1, 2, 3, 4. It is a centimeter resolution. So when you see this image, nowadays you can track your cargo from your office. No need of going to any port. You can track your cargo from your office. That means your technology is very advanced. So you are getting a high resolution data like that. So When we start in 69 or 73 with a 1.1 meter resolution, now we are getting a centimeter resolution. So you are getting a lot of data, then you have to go for an analysis. Whether you are going for an ocean, fisheries, veterinary, or any science, you need a data, right? The data you can extract from an aircraft or a drone or from a satellite. So finally, you are input a different models to get a real world data. So I will not go to the basics of GIS because basically we are calling as a raster. Raster means it is a pixel by pixel. Then the vector means, there is a dot represented by x and y. The second dot will be represented by x1, y1. When you connect with a line, these two nodes are connected with a line, you are calling as a vector data. Finally, you will go for a real world analysis. So when you go for any type of uh, analysis, for example, simple things, suppose you want to study the health risk of a cattle. Okay, so you need a lot of database about cattle. What are the different areas they are moving? What's the altitude of area? What's the type of vegetation like that? So you are getting in a different layers. So these layers you are calling as a thematic layers. Then you want to make a hotspot map for a health. That also you can derive from a GIS platform. So I will show you in the end of this talk how you can apply GIS in the veterinary science part also. So here usually the satellite data is just like a pixels. Already I explained it is just like a raster. The data is look like this. So I already explained it is a coastal area of Kerala. So wherever you are getting a red color, it is a vegetation. And when you get a very bright color, when you see it is a beach on my left side, then you are getting a water. Then inside also you are getting a highly reflecting object, right? So either way, I can classify the water based on the turbidity, and also I can classify the land based on this pixel value. So what I will do, I know these are the pixels. The pixels are arranged in a different number that you are calling as a digital number or pixel value. So based on this pixel value, I will classify this image. Suppose I want to study mangroves or a water. So I will download data from any of the website, maybe from USGS or LPDAP is a Bhuvanis Indian. There's a, if you go to www.nrsa.gov.in, NRSA means National Remote Sensing Service Center. In that, there's another link is called Bhuvan. The Bhuvan, and nowadays there's a lot of sites are called Bhubosh, all the things. You can download satellite data. Once your data is downloaded, your area of interest, your study area may be a small portion, or your project area will be a small. That also, I can subset that image into a small portion. Now I want to classify this data, just like I know this red color is a vegetation, then the second part is the urban area, and third part is the water. Then I will ask the system to classify. Those system will classify into three categories. One is a water, vegetation, and urban area. So how it will be classified based on the pixel value. Those pixel having a similar property will fall under the similar class that you are calling as a clustering algorithm. Suppose you are interested in water, you can again classify water into a less turbid, medium turbid, or high turbidity. That also you can classify water. In vegetation also I can classify different type of mangroves. When it is a coastal area, I can classify into marina or avalocha or rhizopora. Again, I can classify vegetation from satellite data because each object on the Earth surface having its own signature. A word is called spectral signature. Each object on the Earth surface having its own signature. That is why I can classify different vegetation from a satellite data. So I will get an image like this. So my final image for a land use or land cover of a particular state or a district having a number of class. That is based on your experience. You can classify satellite data. Basically, there is a four type of classification: level 1, level 2, level 3, and level 4 classification. So nowadays, UAVs also play an important role. This is one of the image from Dehradun, because what you are getting from a satellite data, the classification technique is entirely different in the case of high resolution data. Your pixel classification will not work in the case of high resolution data. And this is the area you can see. It's a 3D model of that area, and this is a small subset of this area. Here, what we are doing a segmentation instead of classification. For a high resolution, I am talking about high resolution data. Suppose you are using a drone or a WellView 1, 2, 3, 4, or this type of satellite data, or you are using a high drone image, your classification is a segmentation. You are segmenting your area into a different objects. So based on this one only, you are classifying. But in the case of medium and coarse resolution, your classification is basically a pixel-based classification. So finally, this is a part of Dehradun. So I'll get an image like this. So now I can, these are the mango trees. So you can see the shadow is the one class, because where usually I will get a shadow in the image. So that is why when you go for a high resolution data, you need a more space in your lab or a workstation. There's a more computational facilities are needed for a high resolution data. So always keep it in mind. Based on your type of project, you have to select what resolution you need. You need a coarse resolution, medium resolution, or a high resolution. Suppose usually when you go for a planning of your city, you need a high resolution data. So these are the introduction about the subject. So you have any doubt in between, you can ask. So these are some thought about our geospatial technology. These are currently available in the entire globe. We are starting from a satellite nowadays, drone or LiDAR like that. So now I will discuss about how this technology can be applied for a different type of application. So we are also a part of National Wetland Inventory and also for a mangroves mapping. For a both, actually we are doing this. A project was entire for Kerala, entire for India. So we are done for Kerala and Lakshadweep. So the primary aim of space application was to updation of wetland inventory of Kerala and Lakshadweep at a scale of 1:50,000. So they want to also get an information what are the changes for wetland. It is based on the Supreme Court verdict to study what are the changes of land use from 2006 to 2018. That also we had seen, we had carried out from this project. And also the second phase of project is preparation of high resolution data from a list form data. That is about, it's a 5.4 meter resolution. So I will not go to details about wetlands. You are well aware about these wetlands. The wetlands are classified into inland and coastal wetlands. Again, it is classified as a natural, man-made. Then it is based on whether it is a coastal, it is classified into natural and man-made. Inland also classified into natural and man-made. So these are the wetland maps of Kerala 2006 and 07. When you go to www.vedas.sac.gov.in, you can download this wetland maps for both high resolution. You can download to 1:50,000 and 1:25,000 free of cost. It is actually it is a PDF format, and these are the water body look like in a satellite data. Wherever you are getting a black color, the red color is already, I told you, it is a vegetation. So wherever you are getting a red color, you are getting a vegetation. So here it is a red band and a near band. That's a near infrared. So the infrared usually for water delineation, we are using a infrared band. You will not get any information on the red band. So when you compare these two images, you cannot identify water body from a red band. but from a near infrared band, you can easily identify a water body. So these are the some technique we are using, like a water index, normalized difference weightation index, like that. These are the decadal changes for your wetlands. These are actually, I think you are heard about PUFOS having one station in Vaipin, that's a Puduvaipin. You can see what are the changes for wetlands in 2006 to 2018. There's a drastic change you can see on the left side. There is a red color. The red color indicate weightation. Weightation is replaced by there is a grease tint. That means there is a lot of urbanization because that area there is a lot of Petronas, PPCL, a lot of petroleum factories come up after 2006. When you see this image, that means our even in aquaculture ponds on the bottom part, you can see there is a lot of changes for aquaculture ponds also. Some are entirely diminishing from a 2006 when you compare to 2018. Some aquaculture ponds are disappearing. So these changes you can easily map from a satellite data. So this is the second release of wetlands. There's a high resolution data. It is already available, again available in the SAT platform. That's a ISRF platform. You can download this form free of cost. And these are the mangroves community zonation. As far as Kerala is concerned, the aerial extent is very less when you compare to Tamil Nadu or Chilka or some other part of India, in even in Manipur, that area, sorry, in coastal area, you are getting a you are getting a lot of mangrove plantation in Sundarban also. But as far as Kerala is there, it is very scattered. So here also it's funded by Space Application Center to study the mangroves with a 1:25,000. And also we have to generate some biophysical characterization. Here nothing but you have to take some hyperspectral data. You have to take some signatures from the field. So when you see from 2005 to 2017, there is a drastic changes of mangroves, especially when you see the Ernakulam, there is a lot of changes. These mangroves areas are a dumping yard for the waste, and a lot of people are disturbed these mangroves. There is a lot of changes for mangroves in Kerala from 2005 to 2018. And these are the lot of waste dumped in the mangrove area, especially it is near to our campus. There's a wipe in that area, not the main campus. So these are the survey we have conducted for a biophysical characterization. We have done some plots for entire Kerala. And also we are done for some type of analysis for mangroves for a different application. When you see the bottom part, you can see there is a different type of mangrove species. So from satellite data, you can easily identify the species also, whether it is a marina or agalocha or the things based on the leaf structure, whether leaf is a thick or the based on the leaf structure, we can classify mangroves from a satellite data. So these are the weightation and spectral signature. When you see this is a study we had conducted for entire Kerala. So these are the some maps we generated from a chlorophyll concentration, CCA, enhanced weightation index, and higher CCC values are showing an healthy weightation. Suppose you can generate a lot of index. The one of the index is called CCA. The another index is called NDVA. That's a normalized difference weightation index. So if the weightation is very healthy, you are getting a value more than 0.5. Usually NDVA is between -1 to +1. And there's another indicator is a CCI. That's a chlorophyll concentration index. Another you are calling as a EVA also. So these are the monitoring mangrove changes. So these are the false color of temporal spectral ranges. And this nowadays people are using Google Earth Engine, right? Nowadays people are going for a Python or Java. You can see there's a drastic changes from 2002 image and 2020 image. You can see the latitude and longitude. There is a drastic change from 18 years for this island. That is means disturbed lot of mangroves. there is a lot of changes in the structure. So the Google Earth engine is from that you can study the change detection studies. What are the changes for your land or ocean? You can study from a Google Earth engine. So this is one of the things we carried out some 21 years back in Sundarbans, because anyway some audience from different parts of the uh, India. So we had done very long back, 21 years back, to study what are the different characteristics of this Sundarbans. It's this island we are calling as a Sagar Island. So the Sagar Island is famous for Kabilmuni Ashram, lot of things. There's a beach festival, then you are getting a red crab like that. There's a very beautiful, we stayed more than 1 month in this island. The one side it is a Hooghly River, another side is a Mori River. So these are the patterns we are derived, because you can see there is a lot of casuarina. Yeah, other than mangroves, you are getting a casuarina plantation, then sandy beaches, vegetation like this. So these are the different sediment distribution in water of Sagar Island. You can see the other one side is a Nori Ganga. It is carrying lot of sediments from Ganga. Even Hubli is also carrying the same thing. So these are the some of the afforestation of mangrove plantation, and these are the some dunes. It's a beautiful picture when you visit this area. This is an area called Beku Valley. These are the stabilized dunes you can see on the coast of this one. So this is one of the study we are studied what the evolution of Sagar Island from satellite data and also from already data from CWPRS. I think you heard about Central Water Power Research Station. It is in Pune. They have already 1881 data with them. So we compared what are the changes for Sagar Island. Even the shape is changing. There's a lot of changes in the top north as well as in the south portion of Sagar Island for more than 1881 to 1999 data. So, and when you look on the cost of Kerala or India, there's a lot of changes, because maybe there is a mining is going on, especially in Kerala. There's a mining for placer deposits on the Kollam area, and also there is for introduction about the structures in the lot of areas. So that will also create a structure induced erosion. When you see anywhere in India, there's a lot of structures will create a lot of erosions. When you see these are the growing effect, it is on the downstream part of the in Kerala. You can see that there's another in the southern part of Kerala. There's a drastic erosion is happened. So this is a Varkala. Some of the people heard about Varkala is one of the geo heritage sites. Then the Alapi, all the things, there is a lot of erosion is happening. So what we have done for analysis for entire Kerala coast using a satellite data. What are the changes for Kerala coast? It is a more than a 600-kilometer length. The sum of the coast is a very stable. Some is happen erosion. Some area you are getting an erosion. So erosion and accretion is happening seasonally. Then there's a no change in the cost. That's cost you are calling as a stable cost. So when you see this data, when you see for Kerala, when you see from it's a time interval is from 1990 to 2017. There is an erosion length of 327. The accretion length is accretion means there is a deposition of 172, and the stable length is 91 kilometer. So when you say the area, 23 square kilometer lost during 1990 and during 2017, but we gained a deposition of 10 kilometers. So the net loss during this 90 to 2017 is 13 square kilometer. That's the final finding for the entire Kerala coast. So you can do the coastal studies. Suppose you want to study any wetlands or any type of coastal area, that also you can study. And this is one of the biggest Ramsar site in Kerala. Usually Kerala, we have three Ramsar. The one is freshwater, that is Shastangota, then Ashtamudi, and this is a Vembanad. The Vembanad is one of the biggest Ramsar in Kerala. So how this Vembanad is shrinking? Because when you see analyze this data, there's a drastic shrinkage in the area of Vembanad. And this again we have carried out using URLs, using a satellite data like that. So we also monitoring our wetlands. Already I told you there's a three wetlands. This is a, as a Ramsar category. This is the one is called Attamudi. So this Astamudi, we carried out a walk during COVID time. We had seen what's the quality of water before COVID, during COVID, and after COVID. That's the satellite data here we are used is Sentinel-2. Sentinel-2 is a free data you can download from the internet. The data is very with an accuracy of 10-meter resolution. So you can do any type of analysis from Sentinel data. So this is Astamadi Lake. When you see the next image, so here we are calculating SPM. SPM means suspended particulate matter. This is one of the algorithm used to study the turbidity, but the condition is that the turbidity should be below 120 ppm or milligram per liter. You can see using COVID time, you can see the color of your Astamadi was clean, but before and after COVID, there's a lot of red color you can see. So there's a lot of how boating, lot of activities are going on fish. There's a motorized vehicles are going on. So this will give you, you can monitor your Ramsar site from your satellite data as a quality wise. Before we are saying the turbidity is high or low, but one sentinel is there, you can say in a quantify whether it is a milligram per liter that you are calling as a suspended particulate matter, right? So these are again you are calling as a potential fishing zone, because if you go to the website of INCOIS, that's the Indian National Ocean Information System, you are getting a PFZ, potential fishing zone, every day with a latitude and longitude. Suppose you are going to a particular portion of this and Latin lodge, you will get a higher catch. But usually what we are fishing technology, we are using a traditional. I am not saying the traditional is bad, but its own quality is there. So they are using compass and previous experience, then the color of ocean, then bubbles, then the reflection in night, smell, all the things. These are the traditional things we are using, but still also it is working very nicely. That's a traditional knowledge. But nowadays there is a lot of technologies with us to find out what, even nowadays if you have a boat with a sonar, you can find out what's the type of fish also. There's a lot of research is going on Norway, all the things. In for potential fishing zone, what we will do, we'll first map the chlorophyll, what is the concentration of chlorophyll. Then we'll go for an SST, it's a sea surface temperature. Then we are doing a sea salinity, ocean current, everything. Nowadays, there is a lot of models are there. The models will run and it will give you what are the potential fishing zone that you are calling as a PFZ. So you can anyway, the traditional knowledge is well, and also we can use our technology also for further improvement for a better catch. That is why I explained there's a geo AI based technique are coming up. So these are the potential fishing zone. You can nowadays there is a lot of research already carried out by employees with an SST, sea surface temperature, and chlorophyll. You can validate with your catch all the things with a potential zone mapping and GIS. So these are the chlorophyll estimation using an Earth observation satellite. What's the percentage of turbidity or a chlorophyll percent? The same thing you can use for the algal blooms also, because there's some blooms are good, some are toxic. That also can be studied from your satellite data. Here, what is the conventional method? What you are using chlorophyll? You are saying you have to collect water samples, you have to collect and store, then laboratory work, then calibration, all the things. But the remote sensing data nowadays available from a Landsat. The Landsat, the sensor is called ETM, Enhanced Thematic Mapper. The another sensor is called OLA. There's an operational land imager. So from that DN, you can convert your pixel value to a chlorophyll map. That's a very important. So you will get a data on a chlorophyll concentration that you can do nowadays. Nowadays you will get a directly you will get the product. No need of going for this much of exercise. Nowadays you will get a chlorophyll concentration directly from a different sites. Right? There's a lot of ocean sites are available. You can extract a chlorophyll concentration directly from a website. And also, these are the again another map. It is a near to Sundarbans. Here also you can see Sagar Island. You can say it's one of the biggest island. You can see what's the concentration of chlorophyll A like that. So when you see the how your this technique can be applied in veterinary science, because veterinary and animal science, there's a lot of application for this one. Because I am not an expert in veterinary or animal science or fisheries. I am basically from a remote sensing background and GAS. So we are using this technology in different work. We are associated with the last some 10 years back with the CMFRI to find out what are the suitable zones for mud crabs. It is in Saurashtra. Actually, they have given the data for us for Saurashtra with a sample location. Then they are given what is the percentage of sand, silt, clay. Then they are given pH, all the values. Then they are assigned what are the area favorable for mud banks. So we are given this priority from their expertise. So we have classified the data. These are the zones you can go for a mud crab farming like that. You can do any type of application based on your data, because data is very important. So basically, when you talk about this one, there's an epidemic emergency. We can go for a cluster analysis. You want the surveillance. This is spreading modeling. So management strategies. All the things you can do in the in GAS. So when you see in GAS in veterinary practice, you can see there is a lot of things. I wrote. It is already I took from the internet. So communication, monitor changes on disease over time, plan, monitor, intervention, eradication program, emergency preparedness, the management, develop an early warning system, plan and monitor response program, communicate large volume of complex information in simple, effective, and decision making. That is very important. So the decision is very important. You have a lot of database. You need to put in a common platform. You have to get some output, maybe in the form of maps, pie diagram, or spatially how it is distributing. The thing is that if you want to take a decision, you need an appropriate charts or maps. That's whether it is for surveillance or management practice like that. So this is a epidemiology it is used. Animal disease could be understood in better way by using advantage of mapping, location of farms, and other facilities of livestock. So there is a lot of research is going on in Switzerland, all the things in the mapping. Commonly used epidemiology is a presently complicated information. So these are the some of the maps. It is actually not from the India. Also, you have to keep it in mind. So from where which it is started, that's the main important, from where which disease is started. So whether it is spreading towards the north, whether spreading to the south, or it is spreading to the all the directions. So this type of information, you can easily get it from GIS, because once you input any data to a GIS, it will analyze how the distribution of point, whether it is a linear or a non-linear. There's a first conclusion, whether the disease is in the form of linear or a non-linear. So this type of information you can easily track from a satellite. And also you can do a transect also. So whether it is moving from a one point to another point, for a high elevation to low elevation, this type of investigation you can do from a GIS. There's another analysis in GIS is called buffer zone. I think you heard about buffer zone. Suppose there is a forest is there, we are putting as some buffer, because that we are calling as a buffer zone. You cannot do any activity. Suppose you are using a pipeline. There's a heavy pipeline for oil and gas. Then the government will put a buffer. Buffer means you are putting some buffer on the both side of a pipeline. So this buffer zones will help you to reduce the outbreak prone area. So you will make a some buffer for your point from which a outbreak started. So you will put a some buffer source. So this will be very helpful in GIS. And also you can do a clustering analysis because you having a lot of data are there. Sometimes the data is an outlier because it will mislead you. So, but what GIS will do, the GIS will do a all type of clustering analysis or buffer analysis. That is a depending upon type of disease. Also, you have to keep it in mind. So that is a you have an expertise in epidemiology. Then only you can apply this type of tool, right? So you can plan and control strategies that you are calling as a neighborhood analysis. You can do a lot of analysis. And another analysis, overlay analysis that I already explained. Suppose you having a lot of database for a particular area. Suppose you take any part of India. You know, one data is about the elevation data, the slope, whether it is a high altitude or a low altitude. The second is type of vegetation, what type of grass for this type of maybe that one. Then you have to see what are the water source. Maybe it is a wetlands or a water body, whether it is a flowing water. All the things you are getting another layer. So you are getting a multiple layer. You are getting a some 100 layers. Based on this, you will go for a weightage analysis. So from which area is a high risk and which area is a low risk. So same thing we are using for malaria or a vector-borne disease. So we are doing some analysis from where which this mosquito can survive. So you know it is with a water with a low elevation like that. So this type of data you have to generate. Once you are having a lot of data sets, then you have to classify data of your region, whether it is a high risk or a low risk. So once the event is happened or you already having data, you can validate your data also. So this is actually for H5N1 occurrence. It is again in China, this paper, because this is health GIS is already started in India. A lot of people are working, but still it is getting data is very difficult. But there's a no monitoring of data. There is a nobody has recorded any events. Even when you go to the health department, they will not give you data because it is a part of their game. They will not share anything because the data is very important. And these are again foot and mouth disease status for entire globally. So you can see all this data, but the data is again how your map look like based on data. If your data is sparse, it is free. You are free from foot and mouth disease like that. When you see Australia, it's free, right? Maybe I don't know whether the data source is available or not. So these are the something for strengthening our surveillance at local level for early detection, response, and epidemics. So thing is that data is very important. Whether it is a national or international health monitoring system is there, you have to acquire data. For getting data is very difficult. That I am well aware about these things. That is why suppose data is very important. So these are the big data concept for a farming, not in India, I think so. I don't know whether India it is there to monitor your cattle using a GPS, satellite phones for all the things. You can go for this type of analysis, but a lot of foreign countries that are using and this smart control and smart sensing and monitoring and analysis. So I will not go to GPS. The GPS is again to track you to whether your cattle is there. You can track this one. Nowadays there is a mobile telephony, other wireless sensors are there. So these are the conclusion. So GIS can play a vital role for livestock plays an important role in the rural economy of state. That's a potential threat to humans because these diseases are threat. The animal husbandry information system was prepared by taking into account of spatial data. So spatial means, it's a spatially how data look like that. So there is a difference between spatial and non-spatial data. The spatial means with respect to latitude and longitude. Non-spatial, for simple example, I am sitting in a room. My spatial data is my latitude and longitude. What is the height? What is the color? all the things is my non-spatial data. For simple example, suppose if you are going for an animal husbandry information system, what's the position of animal is a spatial data, right? Whether it is in the farm or outside farm. So what is the weight? What is the color? All the things. What is a non-spatial data, right? That is a so GIS is a combination of both spatial and non-spatial data. So I will discuss something about already I mentioned. If time is there, I will spend a 5 minutes for this one. What are the open source data available? When you go to just search in Google OpenStreetMap, you can download a lot of data free of cost. Then there's an Earth Explorer is there. You can download a lot of satellite data. Then if you go to NASA website, or if you go to LPDAC or a USGS, United States Geological Survey, or Alaska Satellite Facility, you can download all satellite data. If you want to study the topography, there is a site called Open Topography. Then there is a Google Earth Engine is there. You can do a lot of wonders from Google Earth Engine. Then there's a Bhuvan is there. It is a National Remote Sensing Center. You are getting Bhuvan that you can download most of data. So I will not go to all the things. I will skip some of the things. Then I will directly come to this one thing you are also using, I think, Google Earth Pro, right? You are familiar with the Google Earth Pro, Wikimapia, Bing Mapia, like that. So when these are the graphical representation, right? So here, see, these are the some of the image from this one. Suppose this is an area called Pettimudi. You can see the image in 2021 and 2020. You can see the changes, right? In 2020, there's a landslide happened. You are getting a slide that's a without vegetation, right? So when you go to Google Earth Pro, there is a in view, there is a option is the historical image. You just slide this one on the top. You can see slide your image from an 89. Nowadays, there's some issue with the Google Earth Pro in India, because when you go to Pakistan, you will get all the images. But India, there's some issue is still going on. But from 20s onwards only we are getting, before we are getting 80s image like that. So from an historical data, you can see that what is the change happened in your area, right? If the grassland is changed, whether more vegetation is happened. So you will get a 3D of your area also, okay? And also I can find out what is this is again a landslide happened. I can find out what is the area also. There's an area here, it is written perimeter and area in square meter. I can find out the length, area, all the things from my office. No need of going to the field. I can get an information from my office. And also I can convert into a KML. Once I am doing some drawing here, I can convert the file into a KML. KML means keyhole markup language. That also I can input in GIS later like that. So I can do a lot of things. This is a Bhuvan. Bhuvan is belongs to National Remote Sensing Service Center. So I will not go to things. I will wind up here. If you have any doubt on this one, you can ask. So these are the some of the data. Some of the FOS4G means free and open source software. Then there's another consortium called Open Source Geospatial Foundation. So the QGIS is one of the wonderful open source software you can download free of course. It is some 2 GB. Before it was 3 MB. Nowadays there is a lot of things happening. It is a 2 GB or 1 GB space you are required. So these are the lot of software also you will get it from the internet. And the data you already shown. There's a USGS, all the things. Google from NRSA website. Then the software also you can download free of cost. So thank you for a patient hearing. So if you have any doubt on this one, you can share this one. So if you
Have any questions, please ask.
I think this is a new area for your